is evaluate the following limits if possible, and there's 4 limits to evaluate. Now the question says if possible, which means that perhaps not all the limits are guaranteed to exist, so I should be prepared for that happening. But of course I won't know until I try them, so let's start. A, the limit as x approaches 0 of x cubed plus 2 all times sine of pi on 2 minus x. Well, both of those things are perfectly good things that exist when x is 0, so I can just bring the limit inside the brackets and do them 2 of them separately and then multiply. That's one of my limit laws. And I can do that limit law because both of the limits exist. The limit as x approaches 0 of x cubed plus 2, I can do that limit, and I can multiply it by the limit as x approaches 0 of sine of pi on 2 minus x. I can do that limit too. So both of those functions, there's nothing wrong with just subbing 0 in because they both exist there and they're nice continuous functions. So 0 cubed plus 2 for that one, and sine of pi on 2 minus 0, so that's just sine of pi on 2. And so we get 2 times whatever sine of pi on 2 is. Let me just draw a unit circle. Pi on 2 gives me this point at the top here, and the y coordinate there is 1, and sine is the y coordinate, so it's 2 times 1, which is 2. Alright, so the limit is 2. Let's do B. The limit as x approaches 0 of 1 on x minus 2 on x squared. Alright, well I can't bring the limit inside and do the subtraction separately because that would only be possible if the limits existed, and the limit of 1 on x as x goes to 0 does not exist. So if that limit exists at all, and I suspect it doesn't, I'd have to do something fancy, like putting them over a common denominator maybe. So let me try that and see if it works. So to put them over a common denominator, so we've got the limit as x goes to 0. Now we'll times top and bottom by x, which will give me x on x squared, and the other one's minus 2 on x squared already, so x minus 2 on x squared. Now the limit of the top is minus 2, and the limit of the bottom is 0, and my limit laws tell me that with a fraction, if the top and the bottom exist, and the top's not 0 and the bottom is, then the limit doesn't exist. So it does not exist. And I should always put my reason down, so let's say because the limit as x approaches 0 of the top, so limit as x approaches 0 of x minus 2 is equal to minus 2, and the limit as x approaches 0 of the bottom, so the limit as x approaches 0 of x squared is 0, and that's the reason why it doesn't exist. Alright, now let's do part C. C. The limit as x approaches a of root x minus root a on x minus a. Well, let's see, the limit of the top is 0 and the limit of the bottom is 0. So if the limit exists at all, I'm going to have to do something special to find it because I can't use the limit laws right now. Well, from seeing others do this, usually you kind of have to factorize or something so that there's something to cancel on the top and the bottom. What could I cancel out? Well, root x is root x squared and a is root a squared, and that would give me the difference of 2 squares. So let's try that one. So this is equal to the limit as x approaches a of root x minus root a on root x squared minus root a squared, and that's a difference of 2 squares, so I can replace it with root x minus root a. Limit as x approaches a of root x minus root a on, so this one is root x minus plus root a on root x minus root a. And then I can cancel the root x minus root a's, and I'll just be left with the limit as x approaches a of 1 on root x plus root a. Because what I've done is I've cancelled the root x minus root a on the top and on the bottom. And now the limit of the top is 1 and the limit of the bottom is not 0, so I can just sub it in. So I get this being equal to 1 over root a plus root a, which is 1 on 2 root a. Now looking at my answer, this isn't going to work if a is 0, so a is not equal to 0, and I should put an a is not equal to 0 here. So that limit is 1 on 2 root a if a is not equal to 0, and if a is equal to 0, then the limit of the top is 1, the limit of the bottom is 0, so the limit does not exist if a is equal to 0. So I should just check to see if any of the other stuff is a bit dodgy. I suppose root x wouldn't be possible if x was negative, so doing that root x squared thing would be a bit dodgy, but that's okay because I've done root x on the top, so x isn't allowed to be negative anyway, and neither is a, because a has to be something that x can get to, so it can't be negative either. So cool, my answer's fine. I should be able to do part D now. So D, the limit as x approaches 2 of x squared minus 3x minus 4 over x plus 2. Well, just looking quickly, the limit of the top exists and the limit of the bottom exists and isn't 0, so I can just do the two limits separately. So let's do the limit of the top. So the limit as x approaches 2 of x squared minus 3x minus 4 over the limit of the bottom, which is x plus 2. So the limit of x plus 2. So that would be 2 squared minus 3 times 2 minus 4 over 4, which is, what's that, 4 minus 6 minus 4, which would be minus 6 over 4, which is minus 3 on 2. And that's the answer. And I should point out that the reason I was able to do that was because the limit on the top and the bottom both exist.